All right, so this is lesson 4. It's polynomial functions and equations. Well, lesson 4, remainder theorem and factor theorem. Now, we saw this sneakily tossed into lesson 3, and I'll show you how it works here. First, I want to do synthetic division on this one. 1, -2, 0 x's, and -4. Again, make sure you've got your placeholders. -1 up front, 1, -1, -3, 3, 3, -3, -7. Now, if I do this with -1 here, -1 cubed minus 2 times -1 squared minus 4, hey, it's -7 also. What a coincidence. Now, similarly, put that down there, 6 out of the way. This is going to be 1, -2, -5, +2, 1, 2, 0, 2, -3. If I did this over here, 4 minus 2 times 4, no, 2 times 2, still not working. Oh, look at me go. Back. 2 times 0 is 0, not 2. Silly McManus. -5 plus 0 is -5, which is, hey, that's cool, because 4 minus 4 is 0, but then -5. Again, -5. Hey, look, they match yet again. This is a cool little thing here, where we say, yes, the remainder is equal to p at -1. Again, the 0 of my thing. The remainder here is also equal to p at 2, the value at the thing. This is remainder theorem. What remainder theorem says is if a polynomial p at x is divided by some binomial, x minus a, the remainder is equal to the value of the polynomial when x equals a, i.e. p at a. Hey, look, I didn't even i.e. on purpose. It was just there. Great minds think alike. The proof of this is pretty cool. So what we're doing is if I'm dividing by this x minus a, instead of d at x, I could write x minus a. So I just made that replacement. Now, to find p at a, I'm going to put it into this form. A minus a is 0. Q at a and r. I don't know what q at a is, but it doesn't matter because 0 times q at a is 0. And so all I'm left with is remainder. Therefore, p at a is the remainder, which is what the remainder theorem says. Cool. So the shortcut here is instead of doing the long division, I can just do p at -1. I don't actually want to do this. All right, I'll show you this one, and then I'll show you how to use your calculator, because I am lazy. Anyway, 6 times -1 cubed minus, let's try that again, 4 times -1 squared plus 8 times -1 plus 6, -6, -4, -8, and +6. These two cancel, so -12, I think, should be what we get. Now, once we've done the graphing section, you might say, well, Mr. McManus, if I was doing this on my calculator, why wouldn't I just do it a different way? But let's put this in. So y equals 6x cubed minus 4x squared plus 8x plus 6. And now I can just go out of here and go vars, y vars, function y1 at -1. See how I did? -12. Huh. It's almost like I know what I'm doing. Okay. If I was putting in a half, I would do the same thing. I would just do p at 1/2. I don't want to do that, so I'm not going to. Again, vars, y vars, function y1 at 1/2. Oh, I missed my start bracket. Insert. You may not have even known that insert trick. It is awesome. Anyway, that's going to be 9.75. Or if I really wanted to look fancy, I can math frac that thing and go, oh, of course, That's just 39/4. I knew that. Yay, calculator. Okay, remainder theorem is 131 when it's divided by x minus 3. We did one like this last time in the last lesson where we did divided by minus 3. So what I would do here is I'm going to put it in like this and go, this is 2, -1, 0, because there's no x squared terms, -8 and 8. And then I'm bringing in 3, because I'm dividing by x minus 3. So 2, 6, 5, 15, 15, 45. This is where it gets rocky, because this thing here would actually be -a plus 45. 3 times that is going to be -3a plus 1. I think it's 150. No, it's not. I've done that. I've made that error before. It's actually 135 because 3 times 40 would be 120, and then 3 times 5 would be 15. 135. 120 plus 15. Anyway, that's the thing. And then this last box right here would be my remainder, right? But they told me up here the remainder is, I think that's 131. Let's check out. Oh, yep, peekaboo. So this is 131. And now I get this equation, which is 8 plus -a plus, no, sorry, wrong green box. -3a plus 135 equals 131, and then I just have to solve 8 plus the 135 would be 143 minus 131 is going to be 12. Bring the 3a to the other side. So I brought this over and put these two things together. This is going to be 3a. A equals 4. Bam. Now, that's how to do it with the synthetic division. Again, it's a little unwieldy. My favorite way is this. P at 3 equals 131. So now I just have to write out P at 3. 2 times 3 to the 4th minus 3 cubed minus 3a plus 8 equals 131. 3 to the 4th is 81, so 162. 3 cubed is 27. 3a, that's going to be 170. Subtract that is 1. Holy cow. Okay, 70 minus 27. 53. 153? No. 43. There we go. Nope. Hold on. There we go. I didn't bring that 131 over. Let's do that. Anyway, so those three like terms together made my 143. Now I bring this over, -3a equals -12, a equals 4. Bada bing, bada boom. Okay, this next example is, I would say, probably just outside of the scope of the diploma. You're probably not going to see anything like this. You might see it on some of your other tests. I doubt you would see it on the diploma. It would be fair if it were there. I just don't think they're going to do it because it requires solving a system of equations, which we've done back in Math 10C and 20-1. But I think it would be a little unfair to have the point rest on whether you correctly solved the equation or not, when what they're really trying to get at is remainder theorem. So I could see them doing something like this, probably not like this. Okay, anyhow, they've just given us two pieces of information. This gives that remainder. No, try that again. The blue, the x plus 3, gives this remainder. And the green gives me that remainder. So now I get two equations. P at 2 equals 74. Or 2 to the 4th plus d times 2 cubed minus c times 2 squared plus 5 times 2 minus 8 equals 74. Now, coordinating that all together, that's 32 plus 8d minus 4c plus 10 minus 8, 74. Okay, 32 plus 10 is 42, minus 8 is going to 42, 30, no, 34, 34. I think 34. So if I subtract that 34 by this 70, I get 40. So 8d minus 4c equals 40. That looks pretty optimistic. Now I can't solve this. This still has an infinite number of solutions. However, there will be another formula over here. P at -3. Couldn't they have given me just one? Come on, people. -41. I am too lazy for all this jazz. 2 times -3 to the 4th plus d times -3 cubed minus c times -3 squared plus 5 times -3 minus 8 equals -41. Lots of terms here. 3 to the 4th is 81 times 2, 162 minus 27d minus 9c minus 15 minus 8 okay. 162 minus 15 is going to be 147, I think. I am doubtful about, you know what? I'm not even going to try and do that one in my head. I'm more likely to make some sort of silly small mistake. And given that I have my calculator right here, why the heck not? Minus 139. Now I'm going to take my -41, subtract my 139. Okay, so I get -180. So my blue solution, -27d minus 9c equals -180. Because this was all still equal to -41. Anyway, that's what I get there. Now I just have to solve my system of equations. Oh, they don't even have anything in common. I'm just going to whine. At least I can take a 9 out of all of this. So if I take a 9 out of all of this, -3d minus c equals -20. And now I'll isolate for c. Now I'm going to put this in over here. Again, you could use substitution or elimination or whatever technique you're rocking here. I'm a substitution guy myself. 4 times 20 minus 3d equals 40. So there's my subbed in for c, this thing in for c. This is going to be 8d minus 80 plus 11. No, 11. 12 d's equals 40. This is going to give me 20 d's equals 80 plus 40 is 120. D equals 6. That's a reasonably nice looking answer. And then if D is 6, 3Ds would be -18, or -3Ds would be -18. 20 plus -18 would be -2. C equals -2. I'm just going to assume that's right because I don't want to check it. But you could check it by putting it back into the other values. I'll check it after the video. I probably won't actually check it after the video, but I'll say I will. Anywho, enjoy your synthetic dividing.